This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. Statistics is not an accurate science. As such, in statistics, we generally allow for our results to differ from the true value. Margin of error is the maximum amount we would expect our results to differ from the true statistic value. We represent margin of error by E, and the formula for margin of error is equal to 1 over the square root of n, where n is equal to the sample size. A small sample size, say n equal to 100, gives us a relatively large margin of error. So in this case, the error would be equal to 1 over the square root of 100, which is 1/10, or 0.1. However, as we increase our sample size, say n equal to 10,000, our error gets smaller. E is now equal to 1 over the square root of 10,000, which is 1 over 100, or 0.01. Following from this, we can say the larger the margin of error, the less accurate the results are. From knowing our margin of error, we can develop confidence intervals. A confidence interval gives an estimate range of values which is likely to include our population parameter. Confidence intervals are about giving uncertainty to our estimate of a population parameter. Usually, we set the confidence interval level at a certain value. Normally, this value is 95%. If we are looking at proportions of a population, this means that we are 95% confident that the true proportion falls within our confidence interval. Or, if we rerun our sample test 100 times, 95 out of 100 times, the true population would lie in our confidence interval. If we want to calculate the confidence interval for a population proportion, it's given by our estimate of the population proportion, p hat, minus the margin of error, which is less than the true population proportion, which is less than our estimate of the population proportion plus the margin of error. P hat is the population proportion estimate, or we also call it the sample proportion. Now, we'll move on to a question where we use this confidence interval. Question states that a random sample of 500 voters were selected for a political poll. 234 out of 500 voters preferred politician A. Construct a 95% confidence interval for the population proportion who might prefer politician A. The first step for this is to get our sample proportion, or our estimate population proportion. So in this question, our sample proportion, p hat, is equal to the 234 voters out of the 500 voters who preferred politician A. And this will give us an answer of 0.468. Going back to our formula, the next thing we need is our margin of error. So our margin of error is 1 over the square root of n, where n is the sample size. So in this case, it's 1 over the square root of 500. And this is equal to 0.0447 when rounded. If many samples of the same size are taken from a population, each sample will have its own proportion. We can make a distribution out of all of these sample proportions. and this will be called the sampling distribution of the proportion. To obtain our confidence interval, we can use the sampling distribution of the proportion. Previously, we used the margin of error. This time, we are going to use the standard error, which is denoted sigma subscript p hat. The standard error of the sampling distribution of the proportion is given by the square root of p times 1 minus p divided by n. Now, in our confidence interval for the population proportion, we will replace the margin of error with our standard error of the sampling distribution. And then we obtain this interval. However, usually we set a level of confidence, for example 95%, so that we obtain the 95% confidence interval for our population proportion. 95% of a normal distribution lies within 1.96 standard deviations of the mean. Please see video on using the normal distribution tables for further details of this. If we wish to obtain a 95% confidence interval for our population proportion, we want to incorporate this 1.96 standard deviations. To do this, we multiply our standard error by 1.96. If we do this, we obtain the confidence interval as outlined in the blue writing. This is a 95% confidence interval for the population proportion using the sampling distribution of the proportion.